Imagine single-handedly taking down a multi-million-dollar e-commerce site on just a random Tuesday afternoon.
Yeah, which is terrifying.
Right. And not because you were hacked by, like, some sophisticated syndicate or because a physical server caught fire in a data center.
No, nothing dramatic like that.
Exactly. No, the entire system crashes simply because you had the wrong version of a software package installed on your personal laptop.
Which happens way more often than people think.
It really does. So today we are looking at why deploying code from your own computer is a massive operational liability. Welcome to your custom deep dive.
Glad to be here.
Since you're clearly someone who likes to peek under the hood of how these massive systems actually function, understanding this specific shift from manual to automated processes is going to be your ultimate shortcut to grasping modern tech infrastructure.
Oh, absolutely. And we are drawing from a really fascinating narrative article today by Aaron Rose. It's titled The Secret Life of AWS Continuous Deployment with AWS CodePipeline.
It's a great read.
It really is. And the author does something unusual here. Instead of, dropping us into a sterile, glass-walled Silicon Valley office, he sets the entire scene in a grand Victorian library in London.
Which I loved. That framing is just so unique.
Right. We follow two characters. There's Margaret, a seasoned senior software engineer, and her junior colleague, Timothy. And the contrast is very deliberate. You have this setting of old world, manual, physical knowledge directly juxtaposed with, like, invisible, cutting-edge cloud architecture.
It makes the abstract concepts feel incredibly grounded. So just picture Timothy sitting at one of these heavy oak desks.
Surrounded by dusty books.
Exactly. And he is feeling highly competent today. He has his infrastructure neatly codified, his API keys are safely decoupled and tucked away in AWS Secrets Manager.
Doing everything by the book, supposedly.
Supposedly. So he just finished writing a quick update to a Node.js checkout, service Node.js being the back-end runtime environment that essentially powers the logic of this shopping cart.
Right, the core engine.
He saves the file, opens up his laptop's terminal, and types in his deployment command. Specifically, he types Oz CloudFormation deploy.
The dreaded command.
Yeah, he is literally hovering his finger over the return key, about to push this fresh code straight to the production backend.
Which is the exact moment Margaret physically intercepts him.
Thank goodness she was there.
Seriously.
Yeah.
She sees what he's about to do, stops him, and asks a very pointed question. She says, "Are you deploying code to our production environment directly from your local machine?"
And Timothy is genuinely confused by this.
He is. From his perspective, his user account have all the necessary administrative permissions, and he just ran the code locally. It works beautifully on his screen.
Okay, let's unpack this. Timothy is authorized. The code functions flawlessly on his specific machine. Why is deploying code that works perfectly well on his laptop suddenly treated like a cardinal sin?
Or Margaret is reacting to what the industry has dubbed the localhost deployment anti-pattern.
Localhost being his laptop.
Exactly. Localhost, in this context, refers to Timothy's actual physical machine. The trap is the infamous developer phrase, "It works on my machine." The problem is that his machine is not the production environment.
The best analogy I can think of for this is it's like baking.
Okay, I like where this is going.
Imagine you are tackling a highly complex, multi-tiered cake recipe in your own quirky home kitchen. You know your oven runs about 10 degrees hot.
Right, the quirks.
Yeah, you know exactly which mixing bowl has a weird chip that affects how you whisk, and you use your specific brand of flour. You can bake a phenomenal cake in that highly personalized environment.
Because you've compensated for all the variables.
Exactly. But if you take that exact same routine and try to blindly execute it in a massive, sterile commercial bakery without standardizing your tools, your ingredients, or your oven calibrations,
It's going to be a total disaster.
a complete mess. The home kitchen is localhost. I mean, I know in my kitchen the smoke detector is essentially my oven timer. If I tried to scale that process, I'd burn down the bakery.
That is a perfect way to look at it, and that scales perfectly to what happens in software development. In the tech world, that quirky home kitchen translates to a phenomenon called dependency drift.
Dependency drift?
Yeah. Margaret points this out immediately. She asks Timothy what happens if his local version of Node.js differs from the runtime actively operating in the AWS production environment.
Meaning he might be baking with a totally different kind of flour without realizing it.
Essentially, yes. Let's say Timothy's laptop is running version 18 of a specific software library, but the live server, the one processing real customer credit cards, is running version 16.
That sounds like a recipe for trouble.
It is, because in version 18, a certain command for parsing data works one way, but in version 16, it doesn't even exist yet.
Oh, wow.
So the code sings on his screen, but the millisecond it hits production, the application throws a fatal error, and the entire checkout service just goes offline.
That's terrifying.
And the risk actually extends well beyond just the software environment. It fundamentally involves human behavior and fatigue.
So it really comes down to human error at the end of the day.
Well, it's worse than just error. It's about reliable repetition.
Yeah.
Margaret highlights the very real possibility of a developer just skipping a mandatory step.
Because they're in a rush.
Right. She asks Timothy, what if you forget to run the unit tests before deploying?
And he's a human being.
Exactly. He might be exhausted after a long sprint. He might get distracted by a Slack message, or he might just be overly confident because the change was, small.
Right. The famous last words, it's just a small change.
Yeah. He forgets to run the safety checks, hits deploy, and injects a bug directly into the live application.
Which brings up the most terrifying part of this whole localhost anti-pattern. If Timothy deploys directly from his laptop terminal, the rest of the engineering team has absolutely zero visibility into what just happened. There is no centralized audit trail.
None whatsoever. If the checkout cart breaks 3 hours later, the incident response team is flying blind.
Which is an absolute nightmare at like 3 a.m.
Oh, for sure. They don't know what code was changed, who pushed the change, or how to roll the system back to a safe state. The only record of that deployment exists in the terminal history of Timothy's laptop.
A laptop which at that exact moment is probably sitting in Timothy's backpack while he rides the tube home.
Exactly.
Relying on human memory to flawlessly execute critical processes, and then relying on a single piece of commuter hardware to hold the record of those processes, that is a massive operational liability.
And Margaret makes this abundantly clear. So Timothy slowly backspaces, deleting the command from his terminal.
I can just picture the defeat in his posture.
Right, but then he asks the most logical follow-up question. If he is forbidden from deploying the code from his machine, how does it actually get to AWS?
That is the million-dollar question.
And Margaret's response is the core thesis of the entire article. She tells him, you don't deploy the code. The cloud deploys the code.
Which brings us to the massive paradigm shift. Margaret introduces Timothy to the concept of CI/CD continuous integration and continuous deployment. And they're going to build this using a service called AWS CodePipeline.
Right, so to clarify those acronyms, based on the source material continuous integration, or CI, is the practice where anytime a developer commits a code change, a system automatically merges it, builds it, and runs rigorous testing.
It's all automated.
Completely. And then continuous deployment, the CD portion, takes over from there. Once those tests pass unequivocally, the system automatically pushes that code into the live environment.
And AWS CodePipeline is the fully managed service acting as the central foreman of this whole operation.
Yes, it is an automated workflow that dictates exactly how code travels from a digital storage repository directly into the live AWS architecture, entirely removing human hands from the actual transfer.
So what does this all mean? Because I have to push back on this concept just a bit.
Okay, let's hear it.
If we are completely stripping away human intervention and we're forcing every single tiny code update to travel through this rigid, automated pipeline conveyor belt, doesn't that inherently slow the engineering team down? Like, if Timothy finds a tiny typo in the code, doesn't he lose his agility if he can't just quickly push a hotfix directly from his machine?
It's a valid question.
Yeah.
But what's fascinating here is that the source text demonstrates how this system actually creates the exact opposite effect.
Wait, really?
Yeah, it seems counterintuitive, but adding a rigid, automated pathway allows developers to move significantly faster.
How does that work?
Well, think about it. When a human is deploying code, speed is directly correlated with risk. You move fast, you break things.
Because you're terrified you forgot a step on the checklist.
Exactly. But in this model, the pipeline is the checklist. It never gets tired, it never gets distracted by a text message, and it never skips a test.
That's perfectly consistent.
Every single time. By establishing this guaranteed mechanism that checks for errors, developers can write code, commit it, and move immediately to the next task.
They don't have to sit there babysitting the deployment.
Right. They operate without the cognitive load or the sheer terror of breaking the live environment.
Okay, that makes a lot of sense. Speed through, guaranteed safety.
Precisely.
So to really visualize how this manufacturing assembly line actually functions, let's follow the journey of Timothy's code as Margaret sets up the pipeline in the AWS console.
The journey begins at the source. That's stage one. Margaret configures the pipeline to connect directly to their shared Git repository, which is the centralized vault where all the developers store their code.
And from that moment on, the pipeline is effectively asleep with one eye open.
It is constantly listening. The second Timothy types git push origin main on his laptop, sending his new checkout service code to that repository, CodePipeline instantly detects the change.
It just knows.
Yeah, it pulls the latest source code and kicks off the manufacturing process.
It's an entirely event-driven system. Timothy doesn't have to log into AWS and press a start button. The system is just watching for his work.
Right, and once it grabs that code, we move into the build phase, stage 2, which utilizes AWS CodeBuild.
And this is the exact mechanism that solves my quirky home kitchen problem.
It is. The text highlights a very specific phrase here. CodeBuild spins up a pristine, ephemeral container in the cloud. We need to dissect that because it's a vital concept.
Ephemeral meaning temporary or short-lived.
Yes, and a container is an isolated, standardized computing environment.
So instead of using Timothy's laptop, which is cluttered with like 6 months of random downloaded files, weird global settings, and an outdated version of Node.js,
CodeBuild commands an AWS server to generate a brand new, completely blank computer environment out of thin air.
wow.
It creates this pristine laboratory specifically for this exact moment.
And then what does it do inside that lab?
It securely reaches into AWS Secrets Manager to fetch the database passwords.
Meaning no sensitive credentials are ever hard-coded in the script?
Exactly, which is huge for security. Then it installs the exact mandated version of Node.js required by production. And then inside this sterile room, it runs the automated unit tests on Timothy's code.
And Margaret sets an absolute unyielding rule for this laboratory. If even one single test fails, the entire pipeline halts instantly.
The assembly line stops completely.
It acts as an impartial gatekeeper, preventing flawed code from ever advancing.
Right. But let's assume Timothy's code is solid. The tests pass. CodeBuild then packages everything up into CloudFormation templates, basically compiling the blueprints, and prepares to hand it off.
Now, this is where reading the article really made me pause, because Margaret introduces a step that feels completely contradictory.
Stage 3.
Yes, stage 3. She sets up a manual approval gate. The pipeline literally pauses its automation, sends out an SNS notification, and waits.
Yeah, an SNS notification simple notification service.
Right, which is essentially AWS's way of shooting off an automated text message or an urgent email to a senior engineer or a QA lead.
To let them know it's ready.
But that person has to review the test results and manually click a button that says approve before the code can move forward.
They do.
Wait a minute. If the entire stated goal was to build a continuous deployment pipeline and eliminate human intervention, why did she just drop a human roadblock right back into the middle of the assembly line?
I get why that feels contradictory. But that apparent contradiction brings us to a foundational concept in enterprise architecture called governance.
Governance.
Yes. While the technical goal is automation, business reality dictates oversight. When you are managing critical production environments, systems, processing customer finances, or handling sensitive personal data, you cannot always have code automatically modifying the live environment without a strategic check.
So she isn't making the process manual again, she is enforcing business oversight.
Exactly the distinction. Think about the labor involved here. The pipeline has done all the heavy lifting.
It detected the code, built the pristine environment,
Installed the dependencies,
ran thousands of rigorous automated tests.
and packaged the blueprints perfectly. The human isn't doing any of that manual labor.
Ah, I see.
The manual approval gate is simply a governance valve. It pauses the automated flow so a human can verify the test results and confirm that, from a business perspective, they're ready for this release.
Like, maybe the marketing team is coordinating an announcement and the code just shouldn't go live until noon.
Exactly.
It's the mission control commander giving the final go for launch, but only after the computers have confirmed all systems are entirely nominal.
A perfect parallel. And once that QA lead clicks approve, the pipeline wakes back up and hands the packaged blueprints over to AWS CloudFormation for the fourth and final stage, the deploy phase.
Now, to be clear on how this final step works, CloudFormation is the service that translates those blueprints into actual infrastructure. But it doesn't just blindly overwrite the existing servers.
No, it is highly methodical. CloudFormation generates what is known as a change set.
A change?
Yeah. Think of a change set, like a red line document in a legal contract. Before it touches the live environment, it provides a highly detailed preview saying, I'm going to add this database table, modify this server, and delete this old function.
And it safely applies those specific updates to the live architecture.
Exactly.
And once the deployment is completely finished and Timothy's new checkout code is happily running in production, code build performs one last crucial task. It vaporizes that temporary ephemeral testing laboratory.
It completely destroyed the container.
It cleans up after itself, leaving absolutely no trace behind except the updated, fully functioning production environment.
It's incredibly elegant.
The mechanics of that conveyor belt are incredibly impressive. But here's where it gets really interesting. Because the true impact of this system isn't just about moving software files around.
No, it's much bigger than that.
It fundamentally changes the engineering team's culture and their security posture. We see this massive realization hit Timothy at the very end of the narrative.
He watches this pipeline run flawlessly from end to end.
Yeah, and he turns to Margaret and says, "This means I no longer need administrative access to the production environment."
If we connect this to the bigger picture, Timothy has just stumbled onto the core security principle of least privilege.
Because the automated pipeline is doing all the heavy lifting and deploying, Margaret can log in and completely revoke Timothy's local admin rights. He doesn't need the keys to the kingdom anymore.
In security architecture, least privilege dictates that an entity, whether that is a human employee or a software system, should only be granted the absolute minimum permissions necessary to perform its specific job. Nothing more.
And Timothy's job is to write code and push it to the central Git repository.
Right. He does not need the ability to manually alter production servers to accomplish that.
So the Git repository officially becomes the single source of truth for the entire company.
Everything flows downstream from there. And this brings us to a vital security mechanism, the IAM service role.
IAM standing for Identity and Access Management.
Right. It's essentially the digital bouncer for AWS. CodePipeline is assigned a very specific IAM service role, a unique digital identity.
Okay.
And Margaret configures the system so that this automated pipeline's identity is the only entity authorized to actually alter the production environment. No human has direct access anymore.
Which completely neutralizes the risk of a tired developer logging in at 2 a.m. to fix a minor bug and accidentally deleting an entire customer database by hand.
You literally cannot do it because your laptop doesn't have the permissions.
It removes the vector for human error in the live environment entirely.
It does. And Margaret points out one final brilliant detail to Timothy. She calls it the best part. The entire code pipeline itself, every single rule, the build stages, the testing requirements, the manual approval gates,
All of it.
can be defined within a CloudFormation text file.
Wait, so the pipeline itself is defined by code?
It is pipeline as code. They are applying infrastructure as code principles to the deployment automation itself.
So it's essentially turtles all the way down. Code building code, deploying code.
Exactly. The release mechanism is now just as reproducible, version-controlled, and testable as the checkout service it was built to deploy.
So if a disgruntled employee somehow manages to delete the entire pipeline, the team doesn't have to spend a week clicking through AWS menus trying to remember how Margaret set up the approval gates.
Not at all. They just run the pipeline blueprint, and the system reconstructs itself from scratch in minutes.
It creates an incredibly resilient operational posture.
It really is a profound shift in thinking. We've watched Timothy go from a junior developer sitting at an oak desk in Victorian Library, literally one keystroke away from introducing total operational chaos from his personal laptop.
To operating within a highly governed cloud-native ecosystem.
Right. He has successfully and happily engineered himself completely out of the deployment process.
And in doing so, he has helped create a permanent, centralized, highly auditable log of exactly what code changed, what time it changed, what tests it passed, and which human approved it.
The engineering team now operates with total visibility.
Which brings us back to you, listening to this deep dive. Because the core lesson Margaret imparts here scales well beyond just AWS or even software engineering.
Oh, definitely.
The principle is universal. Building standardized, automated, highly auditable systems and actively removing the reliance on human memory and individual laptops for critical tasks is how you actually scale a business.
It is the fundamental difference between operating a bespoke craft workshop and running a reliable industrial-scale factory. It is how you manage and mitigate risk at scale.
And practically speaking, it's how you actually manage to sleep at night, knowing that a single typo on someone's keyboard isn't going to bring down the entire operation.
It is the evolution from simply hoping things work to mathematically proving they work every single time.
This raises an important question, though. We've solved the local host problem.
Right. but it does leave us with one lingering, slightly terrifying thought.
Yeah. We talked about how Timothy lost his admin rights and how the principle of least privilege means the pipeline's automated IAM role is now the only authorized entity that can touch production. Yes.
And we know that the pipeline blindly trusts whatever is in the Git repository. The repository is the single source of truth.
The absolute authority.
So if we revoke human access to protect the live servers, and we give all the deployment power to an automated pipeline, if we give all that power to the pipeline, what happens if a bad actor bypasses the servers entirely and compromises the repository itself?
Oh, wow.
Right. If the system is designed to flawlessly, rapidly, and automatically execute whatever code it finds in that vault.
Who is guarding the automated guard?
Exactly. Who guards the guard?
It highlights that in system design, when you close one door, you have to reinforce the locks on another.
Something to ponder as you look at your own workflows, automated or otherwise. Where's your single source of truth? And how secure is it? Thanks for joining us for this deep dive into the secret life of cloud deployments. Until next time, keep questioning the systems you build.